Ever wondered what makes a cube perfect? Today, we're going to break it all down. Here's the plan. We'll start with what a cube is, then get into finding them and their roots. All right, so first things first. What's a cube? It's just a number multiplied by itself 3 times. Take 5, for example. 5 cubed is 125. And notice this works for negative numbers too. And that's a really simple but crucial rule. Positive cubes are positive, negative cubes are negative. Okay, this brings us to the idea of a perfect cube. Let's dig into what that means. So how can we tell? Well, we need to break the number down into its prime factors. When we break it down, we see its building blocks, 3 3s and 1 11. And here's the key. A perfect cube has all its prime factors in groups of 3. See that single 11? Since it's not in a triplet, 297 is not a perfect cube. But now look at 2744. Its factors form 2 perfect triplets. That's a perfect cube. Okay, let's put this to the test. How can we make 3087 a perfect cube? When we factor it, we find a perfect triplet of 7s, but only 2 3s. So we're just missing 1 3 to complete the set. All we have to do is multiply by 3. All right, now let's go in reverse and talk about cube roots. It's the opposite of cubing. There's a really straightforward way to do this, called the factorization method. It's a simple 4-step process. Split, group, take 1 from each group, and multiply. Okay, let's try it with 216. First step, we find its prime factors. And what do you know? We get a perfect triplet of 2s and another of 3s. So now, we take 1 prime from each of those triplets, a 2 and a 3. Multiply them together, and there's our answer. The cube root of 216 is 6. What's great is that this exact same logic also works for fractions and decimals. For fractions, just find the root of the top and bottom. For decimals, just convert first. So, to wrap up, perfect cubes are all about those prime factor triplets. That's the key. Now that you can deconstruct a cube, what other math patterns are just waiting to be uncovered?